Everybody, welcome. So just appreciate everybody joining today for what is the last session, one of the two last sessions here that you can choose from today. And hopefully today's been a valuable, rewarding experience for everybody. I'm going to take a few minutes and talk a little bit about how the session is going to work, although for those that have been in the other sessions, this won't be entirely unfamiliar. And I'll also introduce our two speakers, Ed Robinson and Lisa Spory. Just a reminder that if you have questions throughout the session, you can ask them using the Q&A feature, and at the end of the session, we'll sort of go through those together. And please, as we do this, be mindful of anything that you might want to ask, and feel free to ask as much as you want. So I'll introduce quickly our two speakers. So Ed is an information systems professional with 26 years of experience in the industry, and 16 of those in international development. He manages a software development and deployment team designing and maintaining technical solutions for projects in low resource environments in the healthcare, education, and agriculture sectors. And Ed, when you get your session started, feel free to, or your section started, feel free to add to that. And Lisa, I have the pleasure of working with a little bit here at BAO Systems, where I work. And Lisa has over 20 years of experience in federal IT consulting and software development, and has successfully led software development projects at DHS, the Department of Homeland Security, Department of Defense, and pioneered the application of agile analytics in the federal space. Before she came and joined us here at BAO, she served as the vice president at a technology and IT solutions company that delivers mission control solutions and digital modernization services to the federal government. And now as the CTO here at BAO Systems, she is responsible for overseeing the delivery of a portfolio of lots of different programs across all of our different clients, and implementing agile application development, DevSecOps, and data analytics. And Lisa, please feel free to add anything I may have missed there. So in this session, we are going to talk about DHIS2 hosting requirements and how these have grown in complexity alongside the expansion and adoption of DHIS2. So you'll have the opportunity to learn more about next generation options to support a variety of different hosting needs, from using Docker for containerization to advanced infrastructure design for maximum security and compliance. And we may also talk a little bit about edge computing, compliance, and turnkey interoperability. And both of you, please feel free, again, to add anything I may have missed. I think with that, I will hand it over to Ed to start, and Lisa will take over about midway through.
Thank you. Hey, everyone. Thanks for joining the session. I'm just going to get my slide deck up. Give me a sec to share my screen here. And then I think we should be good. There we go. Right, there we go. Right, as mentioned, I'm Ed Robinson. I'm Technical Director at Project Balance. I've been with Project Balance since about 2016, although I've worked with the team for many years, originally starting at about 2004 when I entered the international development space. In 2004, I joined with a company called Futures Group and worked on a project called AIDS Relief, which was my initial foray into international development. And my first experience with DHIS2 was actually in South Africa on a couple of projects that used DHIS2 back when it still ran on MS Access. And of course, it's evolved a lot since then. So this is really just a brief discussion about DHIS2 and Docker in production, and it's specifically a use case that we've encountered through one of our clients. And just to briefly dip into the water on Docker and what it is, I think it's just important maybe, for those who are familiar with the name but may not be familiar as much with the technology. It's really just a software platform for developing and deploying applications in lightweight virtual environments called containers. It's a form of virtualization, effectively. So talking about virtualization, everybody in the tech field tends to be familiar with virtual machines, and so I did a quick side-by-side comparison, really, virtual machines versus containers. And in the container context here, we're specifically referring to Docker. But with virtual machines, there are two types. There's a type 1, which your hypervisor, which handles the virtualization, the guest OS and your applications, runs directly on top of your infrastructure. And type 2, you would typically run an operating system and you'd run a hypervisor under that, and you would run your virtual machines under there. Of course, type 1 is generally more efficient because you don't have a host OS. And of course, type 2, well, we all run them from time to time on our own machines, especially developers. We tend to run whether it be VirtualBox or whatever hypervisor you prefer. You may have a couple of virtual machines running underneath there. And of course, containers, similar, although the container virtualization happens at OS level. So effectively, these are both forms of virtualization and two of the most common. So virtual machine is really hardware level virtualization. The hardware itself is actually virtualized along with the operating system and the software on it. Virtual machine really provides machine level isolation, and each VM is an independent emulated machine with a separate operating system, drivers, etc. Virtual machines are flexible, but obviously more effort to configure and administer. They're independent machines effectively with their own resources to configure CPU, RAM, storage, etc. And they require more resources. They include hardware configurations and an operating system and applications on top of that. Whereas containers and Docker in particular, they're OS or application level virtualization objects. So containers provide process and application isolation, which is great. Each application can only interact with what is necessary for it to perform its job. And that provides better isolation, and only required libraries for the application need to be included in the containers, which makes them lightweight. So both virtual machines and containers can host multiple applications, but typically a single container will be deployed for each type of application. And I say type very loosely. For instance, you would still have Tomcat and Java typically hosted together. You might have Apache and PHP hosted together in a Docker container. So getting back to our use case, starting off with the old environment. So I worked with the team on a project at national level that kind of inherited an old system from the previous iteration of the same project. The project had a very inefficient and difficult to maintain system. They had two servers sitting at an ISP. They had an aggregate and a tracker server, and there was a firewall/router. And then at the project office, another firewall router and a donor and test instance of DHIS2. There are two different domain names to access the two different systems, and the firewalls used network address translation. So the two servers were accessed on different ports, which made things very difficult to manage. And so the requirements in country were, first of all, in-country data storage, and this is something that we come across fairly regularly. You very often find that on a particular project, you may have a Ministry of Health tell you that they don't want their data hosted out of country. You can really have a strong case for using a higher tier service provider that provides all sorts of infrastructure services and security. But sometimes it's just really difficult to convince the people to make decisions that is a secure environment. And you find that occasionally having data stored in country is a requirement of a project, whether it's aggregate or personal information. Sometimes there really is just that resistance to using a cloud-based provider. And that's what we found in this instance. And what we had was co-location hosting at the local service provider. So actually a local cell phone company, they had a data room with servers, and we could rent space on a rack from them, and we provided the equipment and linked it up. And of course, the other need was to have multiple DHIS2 instances. We needed 2 production instances and 2 QA instances. And we needed to be able to improve efficiency with deployments for testing and new program setup. And so the project replaced the 2 aging servers with more robust machines, 32 and 64 gigs of RAM, new generation Xeon CPUs and larger storage. And we just took that as the perfect opportunity to redesign the hosting architecture. Now, if we go back a little with DHIS2, this is really the typical old style setup for single server environments. You would have your infrastructure, you'd install your operating system, and you'd have all your applications really running on your operating system, and only one DHIS2 Tomcat instance was typically run because of the DHIS2 home environment variable that sort of dictated that. And then, of course, the current traditional method, I call it traditional, is just the old school way of installing all your applications under your main operating system. Now you can support multiple instances on the same machine through the Tomcat instance create method. All components are deployed under the same operating system, and all OS and application processes execute within the same space and occupy the same file system. Now, that is typically a high security risk. We've actually seen scenarios where servers are not well maintained, no security updates have been done over time, and the most common thing to be compromised is Tomcat. We've had a couple of instances where Tomcat, because it's exposed, maybe there's no reverse proxy or whatever the case is, but Tomcat gets exposed and is compromised, and we've even seen malware loaded onto servers and running in the background that way. And of course, access to the file system where servers have been set up badly with root user running all your major services, and then of course with one of those services compromised, there's root access to the file system. So the case for containers, and really it's 3 simple reasons. They provide great security. There's the need for isolation. You can reduce the attack surface area by running containerized applications. So a software vulnerability will only expose the container contents. And then, of course, for practical reasons, running multiple instances of an application on a single server, that's a great reason. And then, of course, efficiency. This is my personal favorite: ability to deploy new instances quickly. It really is a lot easier to deploy once you have the system set up. And so this is really what our production server architecture looks like currently, incorporating Docker. So we have our router connecting us to the outside world. On the servers, we have our hardware, our operating system. We're running Ubuntu 18.04, and then Docker containers are our databases, our Tomcat and Java, and we have additional applications. So we're running a couple of Apache and PHP applications. You'll notice that each Tomcat instance has its own DB, and I'll discuss a little bit about this in a minute. There are people who advocate against running databases and PostgreSQL in production on Docker. And then we use OpenVPN to prevent exposure of sensitive ports. We only expose our port 80 and 443 for HTTPS and HTTP. So our reverse proxy, our Nginx, handles all the input-output via the router, and it assigns the traffic to the different servers accordingly, depending on the URL access, which clean things up really nicely. But with OpenVPN, what we do is we expose OpenVPN to the outside world, and we have certificate-based access to a VPN, which allows us access internally to the operating system level, and allows us to connect to our PostgreSQL servers directly, and obviously SSH into the server and do all of that nice stuff. So right now, the benefits of Docker are immense. Quick and easy deployment of new instances, as little as 5 to 15 minutes for complete DHIS2 instance from scratch now. That includes configuration, and maybe up to 20 minutes if you include image download. We have independent management of existing instances. We can take an instance down. We can take just the Tomcat portion down, do something with the SQL database, bring the Tomcat portion up, which is great. And then, of course, a unified component management tool. So using the Docker management tools, it's a unified system to be able to manage your instances. And of course, improved security and segregation of the different processes. And we use Docker volumes, and that's really to separate data and configuration from the container. This is a really cool feature of Docker. It allows you to have your custom files and data live outside of the container in the host operating system and be shared inside the container. So things like DHIS2.conf, your Tomcat web apps root directory, the Tomcat config file, Nginx config files, anything that's customized within the container, we use Docker volumes to host it on the operating system. And the great thing about that is it means we can deploy a new version of our Tomcat container. Sorry, I've just skipped forward one, I believe. Right, sorry, back to where we were. So it allows us to deploy new versions of our Tomcat and other containers without having to redo configuration, etc. Those files they remain on the host operating system, and they are then linked up inside that container, and the new container runs fairly instantaneously. There's not much to do there. What else is there? So I think really that's the crux of it is quick upgrades and quick deployment of new containers. So in hindsight, is there anything we do differently, and what lessons have we learned? So for our production server, I think what we may do is switch our SQL server as a Docker container. We may switch that for a single SQL instance installed on the host operating system on another machine. We don't really have a unique PostgreSQL version requirement per DHIS2 installation, and doing that will save RAM running a single instance. Storing PostgreSQL data outside of the container on the host machine using Docker volumes doesn't give you any benefit really in terms of upgrades. You will still have incompatibilities when you upgrade the Docker container with major versions. You basically have to do the same process of back up your database, install the new version upgrade, and restore your database. And so for us, that's something we want to consider is maybe moving to an environment where we have a single SQL installation on the host OS rather than PostgreSQL Docker containers. It also means one SQL instance to maintain and upgrade. And then lessons learned. So shared memory size, that's something we came across. There's an out-of-memory error that crept up occasionally, and we discovered that the default shared memory size for PostgreSQL containers tends to be on the lower side. And for DHIS2, we had to up that to 1 gig, which was fairly easy to do with that -shm-size equals 1 GB. And that resolved that intermittent error. And this is typically what we would probably do in future is have our database, single instance hosted on the operating system, and our various Tomcat and Apache /PHP containers connecting to the single host instance, and still have our reverse proxy within a Docker container. And so really the benefit here is we have a single DB instance, lower memory footprint. We have a single DB instance to upgrade. Only disadvantage is all apps share the same PostgreSQL version and configuration, which may be a little less flexible and may be okay for your situation. It may not be. It all depends on your individual scenario. And that's really so. I've got a few links here for further reading. Please do look up Project Balance on LinkedIn. There's a link in the PowerPoint, and follow us. In the coming week, I'm going to release a blog post that takes you through our Docker setup from beginning to end. Just a word on that. Our Docker setup didn't use any special tools like Docker Compose or anything. We use the standard docker.io tools that come when that package is installed. And the reason for that really is it gives you a great overview of the ecosystem. And when you set up a DHIS2 instance from scratch like that, you learn a lot about the system, you understand it better. There are some great command line tools available now provided by the University of Oslo. So if you look at the bottom link, DHIS2 and Docker, you'll see information there, and including some of those tools, those great command line tools that you can use to stand up Docker instances. And then, of course, there's some good reading on Docker itself from the Docker docs, the Getting Started guide and the Docker Compose guide. And that's it. Thank you. Please do pop your questions up, and there is a poll in the poll section, so feel free to take that poll.
All right, thank you, Ed. Let me share my screen. Okey-dokey. So as Scott said, my name is Lisa Sworry. I am the Chief Technology Officer at BAO. I have been with BAO all of 3 months now, so no heckling the new kid from the peanut gallery, please. But as Scott said, I am new to the health and international development space, but I do come with about 22 years experience developing and supporting various applications with about 18 years focused specifically on data warehousing and analytic type use cases. A little bit about BAO for those who may not know. BAO is a company that really has deep roots in global health and international development. And has really branched out to become both a product and service company focused around data. The team at BAO possesses really deep knowledge, both in subject matter expertise around public health and health information systems, as well as extremely deep technical expertise in terms of data science, data engineering, systems engineering, and software engineering. We provide, as I said, a variety of different services and product lines with really the central theme being focus on data. We do data collection, data management, analytics, and we have a variety of product lines centered around these core services in terms of data collection mechanisms such as our Dharma platform, our BAO analytics platform to perform advanced analytics on health and HMIS data, and of course our DHIS2 hosting services. BAO is a technology company that really got started as a DHIS2 hosting provider and consulting firm. And over the years, our AWS cloud-based hosting services has really been the longest standing product and service that we provide. We are at the point now where within AWS, we have about 400 DHIS2 servers that we are managing. And we have a variety of different tiers in terms of hosting plans that go just beyond running DHIS2 in the cloud, but providing more of a platform as a service in terms of supporting upgrades, backups, and built-in redundancy and availability. So again, not just taking DHIS2, throwing it in the cloud and running it for you, but providing more end-to-end platform as a service features. So when we talk about really, what are we talking about when we talk about next generation hosting? What does that mean? As our services and our user base has grown, we're starting to see more sophisticated needs as we get more enterprise level DHIS2 customers coming to us. The standard plans that we offer are really great for small organizations who are mostly self-supporting and they don't have complex data requirements or security requirements. But as I said, over time, we've really seen an increase in the scale and complexity, not only of the DHIS2 code base itself, but also expanded requirements of our users. Talking about implementations in the hundreds and thousands of users, very complicated analytical requirements, customized applications and workflows, and even a demand increasing for security and compliance requirements and support for that. As Ed touched on too, there's also instances where there's countries that have data sovereignty laws that require that health information and PII stays within national borders. And we've also run into situations where you have either a very remote installation and poor infrastructure, or you're trying to support a disaster relief effort that, again, is facing very unstable infrastructure in terms of access to the cloud and even just basic power and access. So within the context of that, we really started to look to Docker to provide the foundation to get us where we knew that we need to be in terms of really offering that next generation of services to our customers and being able to expand our hosting service offering. We also are looking to expand to include multi-cloud and in-country computing use cases, as I mentioned. Our instances right now that we're supporting are in AWS, but looking to be able to also provide that and branch out into Azure. We also really need consistency across the portfolio so that the users that we're supporting with 400 different servers and growing, we need to have a standardized and consistent experience for our users. And containerization really has been able to provide the foundation to provide these enhanced enterprise hosting solutions and be able to scale while providing high level of customer support and stability, because we're doing things in a repeatable way, in a consistent way. So what have we done so far at BAO in relation to Docker? So our systems team has built a BAO systems Docker DHIS2 image. That is a production ready image that has been open sourced and released to the public. You can access it at GitHub on the URL on the slides. Baked into that are a lot of very highly configurable deployment options that are based upon our experience hosting DHIS2 instances for our customers. This includes things like the ability to deploy auto-generated DHIS2 config files, depend on other network services, and initialization and non-interactive startup scripts. We also, in this Docker image, have support for horizontal scaling. So as Ed showed on his diagrams, where you had multiple Tomcat servers running, our image supports that as well. And we actually have BAO Edge servers in sub-Saharan Africa running DHIS2 Docker containers. And again, that's expanding out to the edge computing, which I'll talk about in more detail momentarily. So where do we go from here? As we're looking to really be able to productionize this to help us manage all of our 400 instances, expand out to the other clouds, and work on the edge. We're continuing within our systems engineering group to develop expanded features. So for example, we're working on creating Docker sidecars for helper features so that we can have standardized helpers in terms of log shipping, advanced monitoring and observability, custom maintenance scripts. Again, looking for that consistency on a lot of these cross-cutting concerns. We also are now going to move forward in terms of being able to orchestrate. We need to be able to orchestrate and manage the containers. And so we're going to be moving to Kubernetes for container orchestration so that we can standardize deployment across the cloud offerings and across out to our BAO edge servers. And Kubernetes is going to give us the ability to do that and support multiple platforms while maintaining that level of consistency. Once we have that, then we need to operationalize it and deploy it where we're looking to not only stand up new instances based upon this, but go back and convert existing servers that we're supporting to our new containerized and orchestration platform. If anybody wants to know more about the BAO DHIS2 Docker image that's been put out there, there is a session, a bootcamp session tomorrow being hosted by our own Alan Ivey and Chase Freeman, where they're going to go over and walk through learning how to install and use the Docker desktop for DHIS2 on your own computer, set up a working environment, and work through some use cases around that. So great session if you're interested in diving into more of the technical details. So BAO enterprise hosting, then, as we talk about next generation hosting, is really that next level where we're looking to get as we expand out our offerings of hosting. In a nutshell, enterprise hosting is really a bundling of environments and hosting services with the ultimate goal of really providing a higher level of technical touch to our customers that are enterprise level customers. And so some of the features that are being baked into what we're packaging as enterprise DHIS2 hosting include providing multiple environment support so that you can have development, test, stage, training environments so that you can control the deployment of flow of code through a true pipeline, including opt-ins for automated DHIS2 patching and upgrades, advanced monitoring tools and advanced server health monitoring features, elastic sizing and auto scaling to be able to really expand and collapse with fluctuating demand, as well as integration with some complementary BAO products such as our Dharma platform for data collection or our analytics platform for doing advanced analytics and reporting on DHIS2 data. Also looking to include in that quarterly server health reports and really more of an engagement from an account management perspective around really working with our enterprise customers to look at the health of the system, look at the forecasting of sizing and demand and needs, and really work hand in hand in collaboration around the budgeting and the planning around supporting an enterprise instance. We're also looking at offering some advanced optional add-ons for people who need it. One of the biggest areas where we've seen that is in the area of security and compliance. So some of the options that we're offering are, for example, web application firewall, deploying WAF, being able to set up and routinely run Nessus scans, app scan, and then even going beyond to engage in a full compliance as a service type model if there is an enterprise customer that needs to get through a very rigorous security audit such as FISMA or FedRAMP. Also looking to be able to optionally engage with customers who would have a need for really high availability infrastructure requirements where you need to have an immediate active disaster recovery solution that can immediately flip over with zero downtime being acceptable. And the potential to engage for any kind of real true critical incidents response. Again, servicing more of these enterprise customers who might have much higher levels of mission criticality around their installation and deployment. So why would this enterprise hosting, enterprise DHIS2 hosting be right for you? I think if the word enterprise is in your system, that might be a good tip off right there. Really, anybody who's doing an enterprise or institutional level MIS, if you have a global level project with thousands and thousands of users, if your DHIS2 implementation is using complex workflows, custom applications, and really a lot of complexity that's requiring really stringent testing and control through DHIS2 upgrades and other consuming of server resources. I mentioned if you feel that you really need to have either high availability or there are extreme peaks in demand where there would be a need to have a hosting solution that is going to be able to expand and collapse as you go through periods of surge in terms of your user base. So if there are times of the year where you have really increased demand for reporting or massive data imports happening, and you need the ability to expand and collapse to adjust for those workflows, enterprise DHIS2 might be useful for that. As well as anybody who really needs to have more granularity and information about their server health so that they can really do much more proactive and detailed planning and budgeting for future needs. That would be another reason to look at moving to an enterprise DHIS2 hosting. So the edge. So what is BAO edge and what is edge computing? Edge computing is really a paradigm where you're bringing computing services closer to the consumers or data sources, rather than trying to bring all of that processing and all of that data up to the cloud. It typically can be done and used in industries like manufacturing, robotics, AI, and machine learning, where you have either massive amounts of data that's being collected at the edge with sensor data, for example, that needs to be processed, and there's limitations and reasons why you wouldn't want to try to complete that processing and bring it all the way back up to the cloud. So it's layering out where the data is residing, where processing is happening that most makes sense, really given the reality of infrastructure and your ecosystem and the data. BAO Edge is taking this concept then and bringing DHIS2 hosting out to the edge. And in this situation, it's more to address the issues around data sovereignty and the stability of infrastructure and internet access than necessarily high volume like AI and machine learning data processing, but the concepts are the same. So we envision supporting different edge deployment scenarios. A very simple scenario is really, again, driven by data sovereignty. You have PII data and health data being collected in DHIS2, and basically that data is not allowed to leave the borders of the country. So it is not practical, it is not legal to be able to take that data and host it in a cloud instance of DHIS2. In that deployment scenario, you would have a BAO edge device that would stay out in country and serve as the in-country repository for that data. That's a simple use case. There are potential for there to be hybrid options, though, as I talked about with more traditional, when you look at just edge computing, where there's layers of processing that's happening at different levels. So there can be deployments of BAO Edge where you would have that patient level, personally identifiable data living and staying at the edge in a BAO Edge box, and patient level data that's being aggregated and obfuscated, basically the PII removed from it, being pushed up to a central cloud-based DHIS2 instance or other data store. That would be doing the individual level collection in country, but allowing there to be higher level reporting in the cloud for the roll-ups and the aggregate level data and information. Another use case we envision would be where the actual data and the DHIS2 instance is running in country, but it may be allowable that a backup could be stored on a secure cloud server that would not be accessed by end users, but that would give a really great, easy and cost-effective way to manage backups, because that is one of the challenge with the edge and when you're working on edge computing. Unless you're going to have physically separated another device ready and accepting backups, you really need to have a backup solution. And so a great way to do that, if it's allowed, is to be able to send those backups up to the cloud, but not actually run any DHIS2 instances in the cloud. And other use cases as we look out and to the future would be, again, I talked about there being sensor data being collected and pushing that to the edge in terms of being able to aggregate very low-level sensor type data to very cheap edge devices that's then being aggregated and sent upstream ultimately to be consolidated for analysis in a data store that may live in the cloud. So just to summarize, why would you necessarily want to use edge? What are some of the use cases around that? Definitely data sovereignty is a big one. If you have data that just cannot leave the country and cloud-based hosting is not an option, edge is a good solution where you can keep the data in country and BAO will manage that DHIS2 instance remotely on your behalf. So you're able to have a hosted instance without having to actually have that data leave the country. Another great use case or reason to look at expanding to edge would be for implementations where you really don't have stable internet connectivity and you're not going to be able to have and be able to support a solution that requires consistent internet access to be constantly using a cloud hosted solution. Similarly, it could just be latency issues. So maybe the internet connectivity is stable, but it's very slow and it's just not feasible. These would all be reasons to look at potentially leveraging an edge device, either in a completely on-prem isolated instance or looking to do some kind of a hybrid solution to bring some of that data up to the cloud. And that's all I have. Scott, I will turn it back to you if there's any questions for Ed and I. Thank you.
Great. And so far, I only see one question in the Q&A. If anyone has any others, feel free to add them in there. But I'll summarize. Bob has asked, Ed, when you run the PostgreSQL on its own outside of containers, how can you ensure that PostgreSQL doesn't greedily consume all their resources?
The hard questions for me. Yeah, that's a very good point. PostgreSQL itself doesn't have any sort of mechanism to just say limit memory. It's not an easy thing to do, short of tweaking. A lot of the work mem and other settings. It's a bit of a trial and error game on that side. For our situation, what we'll probably end up doing is we'll split up the PostgreSQL onto its own dedicated box and have the main box running exclusively, for Docker. That's more than likely the easiest way to deal with it. Having it outside of a container, it does tend to be a bit of a resource hog. But absolutely, there are things that can be done within Postgre itself. But yeah, it's an ongoing challenge. Getting resources for PostgreSQL tweaked can be a bit of a nightmare sometimes. I don't have a clear answer for that. If that's, I apologize. I'm sure you've probably experienced a lot of this yourself, judging by the question. Yeah, C groups, of course. Yeah, so there's a great opportunity. I guess we run out of time, but to have the Docker LXD discussion. LXD is actually a great system, and that's kind of where it all started for me in containerization. In fact, your scripts, Bob, have been really, really useful. We've used them in trainings, and it was a really great experience. And of course, the big difference, I guess, is the fact that your container is effectively virtualizing the operating system and apps, whereas Docker is really just lightweight, geared specifically at apps. So there's a lot of goodness to that. Obviously, resources may be a little heavier, but there's definitely benefit to containerizing things at the operating system level as well. And absolutely, I encourage people to explore LXD as well. Have a look at Bob's scripts on GitHub. There's some great stuff there.
And I don't think there's any reason why we can't take another question. So Lisa, there's one for you that says, can you talk to what good environmental management discipline involves?
Really what we're looking to do here is to be able to standardize deployments, standardize configurations through containerization. Really, again, it's to drive that consistency so that you're not looking for relying on manual discipline when you're managing various servers. I would say the goal is to automate wherever possible. And that's really where we are trying to move to and looking to leverage containerization and orchestration to be able to handle that for us, to have the orchestrator be able to manage the containers on our behalf and focus more on being able to monitor the services and the quality of service that we're providing to our customers.
Yeah, I guess I'm going to just pop in there. I'm not sure, but I assume you're referring to server maintenance as well. So, I mean, what comes to mind when I hear server maintenance is keeping things up to date, really important software. Prioritize security updates, don't slack off on those. That really is important to keep software up to date today. If you want to look out for a couple of CVE bulletins out there and subscribe to them and look for all your major products on those lists to see when new vulnerabilities have been identified and take action. But definitely make sure that you're doing regular, at least, security updates on your server. And of course, when you deploy, always consider the principles of least privilege. Don't assign rights to users or processes that don't need those rights. Lock everything down. If there is a breach, it will basically reduce the attack surface area and limit the damage. Things do happen to the best of us. I mean, we're seeing people in the news every day. We saw Microsoft recently, huge companies with massive budgets and massive cybersecurity budgets that are, having to deal with breaches. It's often not a case of if, but when. So it's really important to be prepared, and of course, backups. A number of times we've heard of organizations that have been compromised, and whether it's ransomware or whatever the case is, they've lost their data and they've lost their backups because they've all been on the same system, or the backup is available from the compromised device, or whatever the case is. But there are horror stories out there. So definitely principles of least privilege and backup are really important pieces. And it's an ongoing thing. It's not just a case of set and forget. So do check up on your servers, check logs, consider using third-party logging services. Datadog and others provide you with insight into your server with really nice interfaces, be able to see how things are going. And there are other providers, intruder.io. Will give you insight into any vulnerabilities, known vulnerabilities on your software platform, etc. But maintenance, I think, really, around security is probably the most important aspect.
Yeah, that is a very important incentive to know what you have running where at what version, right? And that's really what a lot of this is about. I mean, especially when you look into a lot of vulnerabilities being around library and dependencies. I remember the days when we used to do manual deployments, and we were looking at file sizes to figure out what version of a library do we have there, right? Because it was so difficult to tell and to know, was it put on every single server that we needed it to be, and really trying to go through that troubleshooting. And as you start to manage more and more instances of servers, you can't be leaving that to guesswork, right? That needs to be packaged together. You need to know what versions of containers are running where. And yeah, as Ed said, that becomes absolutely necessary in this world where security vulnerabilities just fly all the time out of nowhere, right? And you have to respond so very quickly.
Yeah, exactly. It happens overnight. You know, what works today, you know, doesn't necessarily work tomorrow. You may have vulnerability tomorrow. It's a constant battle. It is a part of the job, and I think it just needs to be put into the budget. You know, keeping systems secure is everybody's work, and it's, you know, I think that's, I guess, a talk for another day. But security is everybody's problem. You know, very often the threat is on the inside, and it may not be intentional, it may not be malicious, it may just be an accidental email that was, you know, clicked. Somebody fell for a cleverly designed phishing scam, whatever the case is. But those threats are very real. And please don't expose your sensitive ports on the internet. I see it again and again at large organizations where SSH and other ports are exposed of the internet with poor security, you know, maybe even password-based security, etc. At least have a VPN or something. Hide all your sensitive services behind that, your RDPs and things like that. And really, there's good free software out there to set up VPNs. There's no need to have systems be exposed like that. I think if you just look at the logs of attempted breaches or attempted even just logins to services like SSH and RDP on any system, you'll be quite shocked to see the number. I mean, I've seen servers with thousands of attempted brute force attacks on an ordinary day to an RDP port that's out and open. It's like a red flag to bad actors.
Yeah, so I'm coming to BIO from a world where security compliance is the name of the game. You know, I've spent the last 15 years, for example, supporting Department of Homeland Security, where everything we did had to go through extremely rigorous security and accreditation processes. One of the driving reasons why my application development teams and my systems teams, we were pushing to go to infrastructure as code and continuous integration, continuous deployment type environments, is to be able to push this concept of compliance as code, right? Where the security compliance becomes part of your infrastructure and your code deployment pipelines. You're running the security scans, you're deploying hardened images, you have control, inventory, versioning over all of that, with really that ultimate goal to being able to ensure programmatically and through that infrastructure as code and continuous delivery and integration services that you are always in complete compliance. I spent a lot of time at USCIS, which is United States Citizenship and Immigration Services, and I was able to get my teams to a point through automation and through following these practices where we stopped going through an annual recertification process from a security perspective, and we moved into a model that was called continuous approval to operate. And that's basically because we got so automated to the point we were running our scans as part of our code deployments. We had the appropriate agents running where we needed to have, we were tagging servers that were up. All of that was automated to the level where security was able to say, all right, we're going to routinely look at your scans, we're going to look at your security logs, but we trust you to be constantly compliant. And that really becomes the goal. I mean, yeah, we talked a lot about standards and services, but yeah, I mean, to Ed's point, security is really the crux in a lot of this.
Thank you to both of you for your insights and your help, and for the questions in the Q&A and in the chat.